In this video, we're going to talk about simplifying trigonometric expressions. And to do that, we're going to need, for these examples, the instructions say use the Pythagorean identities to simplify the given expression. And here I've listed the 3 Pythagorean identities that we are going to use to simplify. I'm going to show you various ways of simplifying number 2. We're going to do it with the Pythagorean identities and also other ways. Okay, number 1 says 1 minus secant squared of t. Now, as soon as I see secant squared, some students will have the habit, due to the teacher's instructions, that anytime you see something other than sine or cosine, go ahead and make everything sine and cosine first. But for this example, I'm going to discourage you to do that because I have an identity which uses secant squared. This one right here. Secant squared of t, which I can use directly in this example. So I'm going to go ahead and use this identity, and this becomes 1 minus. And since I have a minus, I'm going to write a parenthesis because this minus is going to affect everything that I write inside this parenthesis. 1 plus tangent squared of t. Now secant squared of t, I substituted for what that is, which is 1 plus tangent squared of t. And now I'm going to distribute this negative inside this parenthesis, and I get 1 minus 1 minus the tangent squared of t. 1 minus 1 is 0, so I'm left with negative tangent squared of t. And this is your answer. This expression simplifies to this value. If you go ahead and change this secant into 1 over cosine squared of t, you can go ahead and do that and try it out and see where you get. See if you get to the same answer. These expressions, there's so many different ways in which you can attack them, but with experience and with a lot of practice, you will get the knowledge of what is best to approach the expression. Okay, so at the beginning, if you're starting out with it, you're going to make a lot of mistakes. You're going to go on the wrong path. It just takes you that to make mistakes and go on the wrong path and start over and over and over until you reach the answer in the shortest amount of steps possible. Okay, but it takes practice. For example 2, I have sine squared of t plus cotangent squared of t times, this is multiplication here, times sine squared of t. Okay, and since the instructions say to use Pythagorean identities, here's what I'm going to do. I notice that I have 1 term, 2 terms in this expression separated by a plus sign, and both these terms have a common factor, and that factor is sine squared of t. So I'm going to factor out that common factor. Sine squared of t is the common factor, and then inside the parentheses I'm going to be left with 1 plus the cotangent squared of t. And now all we need to do is reference our Pythagorean identities, and I have an identity here that says that 1 plus cotangent squared of t is cosecant squared of t. So I can substitute this whole expression here for cosecant squared of t. And now I have a multiplication of sine and cosecant. So I know cosecant squared is the same thing as 1 over sine squared of t, okay, from the basic identities of trig. And now these two cancel out, and this will equal 1. This example I'm going to redo here as a number 3 so that you can see another way that you might have approached it using not the Pythagorean identities, but the basic identities. What are the basic identities? Well, there are a lot. Sine of t is 1 over cosecant of t. Cosine of t is 1 over secant t. Tangent of t is 1 over cotangent of t. And it is also equal to sine of t over cosine of t. And cotangent of t is 1 over tangent of t. And it also equals cosine of t over sine of t. Okay? And cosecant of t is 1 over sine of t. Let me scroll down a little bit. Cosecant of t is 1 over sine of t. And secant of t is 1 over cosine of t. Okay, there you have them. Now this problem here that we just did in the previous example, we can do this another way. I can use the basic identities. I could have said, well, sine squared of t plus cotangent squared of t. I'm going to go ahead and change that to cosine squared of t over sine squared of t, because that's what cotangent is. See? Cosine over sine times sine squared of t. So all I did here was change cotangent in terms of cosine and sine. And this is usually our first approach. And now I have sine squared of t plus, this is a multiplication, so this cancels out with this, and I have cosine squared of t. And by the Pythagorean identity that we have up here, cosine squared of t plus sine squared of t equals 1, then I can say that this is equal to 1. Notice the same problem we did twice using different identities, and we got the same answer. So there are different approaches to this. It takes practice and experience. Now the instructions do say to use the Pythagorean identities. So I encourage you for these problems to use these 3 and try to figure out how we can use these in these examples. But know that you can also approach it differently and get the same answer. Okay? I hope this helps. Go back, do these on your own, and check if you get the same answers. I will see you in the next video.